Example problem 4.10 gets us into static friction and kinetic friction. We're given the coefficient of static friction, mu s is equal to 0.65. The mass of the crate is given as 40 kilograms. And we're given that the coefficient of kinetic friction is 0.50. So question A asks, what minimum force is needed just to get the crate moving? Well, in order to get it moving, we have to overcome the force of static friction. The force of static friction is easily given by the equation, the coefficient of static friction times the normal force, which, if the object is horizontal, should be mass times the pull of gravity. It's actually mass times the pull of gravity times the cosine of the ramp angle. But so we'll throw that in there, cosine of the ramp angle. But the ramp angle is at 0 degrees, and the cosine of 0 is 1. So the equation for the force of static friction is coefficient of static friction times mass times gravity times 1. And that looks like we're going to get the right answer if we plug in the knowns. We look at it, and it tells us, and the force of static friction will be able to work it. So we plug it in, and sure enough, there's a solution. And the guy's pulling the crate, and we go to the math part, and there it is. The equation given to us. The force of friction is the coefficient of static friction times the normal force, which is, in this case, mg. So we get the force of static friction. Well, if we apply that amount of force, and it's given to us as 255 newtons, now we're asked for part B, what will the acceleration of the crate be once it gets moving? Well, we can do a free body diagram, and we're applying a force of 255 newtons, but we have to oppose the force of kinetic friction, which will be going in the opposite direction. So you can throw a negative there. You can look at your free body diagram and see it's going in the opposite direction. Now, the force of kinetic friction is also given as the coefficient of kinetic friction times the normal force, which is mg. And the net force, the sum of the forces, is going to be the force we apply, the 255 newtons, minus the force of friction, kinetic friction. So we work out the units and we work out the numbers, and it gives us a force of kinetic friction, and then it'll give us a net force. Now, in your book, it adds these equations together. So it says the acceleration would be equal to the net force, the sum of the forces, divided by the mass of the system. And so the acceleration of the system would be equal to the 255 newtons minus mg, coefficient of kinetic friction, divided by the mass of the system. We can't cancel out these masses because this is being subtracted from that number. So we have to work out the numbers, and when we do, we'll find the acceleration of the system. So it's pretty straightforward. The second problem, 4.11, can be worked out in the same way, and we'll do that next.